To solve a problem, you can use what we call dimensional analysis or factor label. So here are some steps that you can go through when you're trying to solve a problem using this method. Of course, you always want to read your problem, and I'm going to teach you to circle and underline your given and your unknown in your problems. So that will be your given quantity that you'll underline, and the unit that you want will be what you circle. Now I'm going to show you that you can also write them down as well. You're going to select conversion factors that you're going to need to use. You're going to set up a problem using those conversion factors. You're going to cancel your units and double check to make sure that they all really do cancel. You're going to do your math, and then you're going to give an answer using the correct significant figures. So here's some conversion factors that are pretty common. We know that 1 dozen is equal to 12 of anything. 100 years is a century. 100 pennies is $1. 4 quarters is $1. A quart is 4 cups. All of these things are equal to each other. All right, so keep that in mind. They're equal to each other. So you can put those conversion factors into fractions. And remember that anything divided by itself is 1. So for example, if 1 inch is equal to 2.54 centimeters, then 1 inch over 2.54 centimeters is actually equal to 1. Now they are in different units, so we can say that they're the same. And then we can also flip that and use 2.54 centimeters is equal to 1 inch. And both of these are going to equal, like I said, they're both going to equal 1. So what we're doing is when we use dimensional analysis, we are basically doing conversions. We're going to be multiplying by 1. So how many minutes are in 2.5 hours? Now, I'm sure that you guys would pull out your calculator, and you know that there are 60 minutes in an hour, and you would be multiplying, and you would have your answer in no time flat. But let's see how that would actually work out. So we're given 2.5 hours. We're trying to find minutes. So we need a conversion factor, okay, that's 1 hour equals 60 minutes. Now, which way are we going to put this? We can either do 1 hour over 60 minutes, or we're going to do 60 minutes over 1 hour. Well, let's set up our problem and see. So if we start with our given 2.5 hours, then we're going to need to use this particular fraction, 60 minutes over 1 hour, so that the hours cancel. Okay, because this just becomes one big fraction. Because remember, 2.5 over 1, anything can be considered a fraction by putting it over 1. So your answer here is equal to 150 minutes. So by using dimensional analysis or the factor label method, the units are going to ensure that you have the conversion right side up. The units are calculated just like the numbers. All right, so we treat these units the same way you guys treat ABCs or XYZs in algebra. So here's another example that would be pretty common, and you could solve this with no trouble. So you have $7.25 in your pocket in quarters. How many quarters do you have? Well, following our steps, we can see that we have dollars and we're trying to go to quarters. So we need a conversion factor. So we know that $1 is going to equal 4 quarters. So if we start with $7.25, then we're going to want to set up that conversion factor by putting 4 quarters over $1. And of course, the reason we want to do that is because we want dollars to cancel. Excuse me, so those will cancel, and we're just left with some multiplication here. So we know that we have 29 quarters. For most dimensional analysis problems, we're going to be dealing with units that are not as familiar. So these prefixes are ways that we can express really big numbers or really small numbers in a more manageable way. Now, you guys are probably familiar with centimeter, millimeter, and maybe even decimeter, kilometer, but there are many others that we're going to be using in chemistry. And you don't have to memorize these or anything like that. If you need them, you'll be given what that conversion factor is. We'll also be using what we call cube units from time to time. But again, you'll be given what these things are equal to. And of course, the temperature conversion we'll get to a little bit later. So here's an example problem. How many micrometers or micrometers, are in 7.25 meters? So we're going to need to go from meters to micrometers. So if we look back, here's micro. So the way we read this is that this would be 1 micrometer is equal to 10 to the minus 6 meters. And we can substitute meter for second or liter or mole or any other base unit that we have. So 1 micrometer is 10 to the minus 6 meters. So we're going to set this up. We're going to start with our given. You always start with your given there. And remember, we can put this over 1. Now, we want meters to cancel. So that means we're going to need to make sure that we have meters on the bottom. So this is 10 to the minus 6 meters on the bottom and our 1 micrometer on the top. So that when we put this as one big fraction here, my meters will cancel. Alright, so that leaves me with 7.25 over 10 to the minus 6 number-wise. And so you can either put that in your calculator or remember your rules, and it would be 7.25 times 10 to the 6 micrometers. Okay, let me find my next slide. Oh, sorry. There we go. How many seconds are in 9.56 times 10 to the 10? This is a pettasecond. All right, capital P. So here's our capital P. So 1 pettasecond equals 10 to the 15 seconds. That's how we are going to do that. So we're going to start with our given, 9.56 times 10 to the 10 petaseconds. Okay, again, if you'd like to put that over 1, you can. So we need for petaseconds to go on the bottom. So we work diagonal and seconds on the top. So we have 1 petasecond and we have 10 to the 15 seconds. Alright, so now we can check and see that things cancel and we're left with what we want. So we get 9.56 times 10 to the 10 times 10 to the 15 over 1 as far as our numbers go. So you can plug that into your calculator or remember that you add your exponents and your answer is 9.56 times 10 to the 25th seconds. Now we're going to have prefix to prefix conversions from time to time, which means we're going to have to use more than one conversion factor. So the first factor has to go to the base unit and the second will go to our desired prefix because all of our prefixes here are equal to our base unit. So for example, 83.2 milliliters to nanoliters. So we're going to have to go from milliliters to liters to nanoliters. So if we look at our prefixes, we see that 1 milliliter is 10 to the minus 3 liters and 1 nanoliter is 10 to the minus 9 liters. So if we start with our given, 83.2 milliliters, all right, we want to cancel milliliters, so we're going to put that on the bottom. Now we have to go to liters here because that's what our conversion factor is. So 1 milliliter is 10 to the minus 3 liters. All right, so now that cancels. So now we need to cancel our liters here. So we put liters on the bottom, nanoliters on the top. So then we look at our numbers. 1 nanoliter, 10 to the minus 9 liters. And our liters cancel. So our liters cancel, we're left with nanoliters. So now we have 83.2 times 10 to the minus 3 over 10 to the minus 9, and we can plug that into our calculator, or we can solve it using our exponents. So if I do that, I would do 8.32 times 10 to the 1 for that guy, and that would make my math a little easier. And my answer would be 8.32 times 10 to the 7 nanoliters, because we would have 10 to the minus 2 over 10 to the minus 9. So minus 2 minus a minus 9, we subtract, so you get 7. All right, next example, 1.58 times 10 to the 12 femtograms to kilograms. So femtograms to grams to kilograms is our plan. We look in our conversion chart and we see 1 femtogram is 10 to the minus 15 grams, and 1 kilogram is 10 to the 3 grams. All right, so we want to go ahead and start setting things up. So we get 1.58 times 10 to the 12 femtograms. Okay, so femtograms needs to go on the bottom, and then we're going from femtograms to grams. So 1 femto is 10 to the minus 15 grams. Now we need to cancel grams, so we put that on the bottom. We're going to kilograms. So using our conversion factor here, 1 kilogram is 10 to the 3rd grams. Check to see that things cancel, and they do. And so now it just comes down to doing your math. So 1.58 times 10 to the 12 times 10 to the minus 15 over 10 to the 3rd. So we get 1.58 times 10 to the minus 3 over 10 to the 3. So minus 3 gives me negative 6. So my answer is 1.58 times 10 to the minus 6 kilograms. Now, sometimes you'll have a derived unit, or a unit that is a fraction, like meters per second or grams per milliliter. And in this case, we have to do a plan for both. So if we're going to go from 4.65 grams per milliliter to milligrams per liter, we need a plan to go from grams to milligrams and from milliliters to liters. So the conversion factors that we're going to use, 1 milligram is 10 to the minus 3 grams, and 1 milliliter is 10 to the minus 3 liters. All right, now make sure that when you set up the problem and you write your given, you're going to put the 1 unit over the bottom unit, because that really says 4.65 grams in 1 milliliter. Just think of miles per hour. You go that many miles in 1 hour. So now we're going to focus on top and bottom. So if we want to cancel grams, we're going to need to put grams on the bottom. And so we're going from grams to milligrams. Now if we stop here, my unit will be milligrams over milliliters. All right, let's fill in our numbers then. We have 1 milligram is 10 to the minus 3 grams. Now, we don't want milligrams per milliliter, so we need to cancel milliliters. So the way we do that is we want to put milliliters on the top, and we're going to liters on the bottom. So if that cancels, we're left with milligrams over liters, which is what we do want in our problem. So let's plug in our numbers. 1 milliliter is 10 to the minus 3 liters. So we end up with 4.65 over 10 to the minus 3 times 10 to the minus 3. So my answer is 4.65 times 10 to the 6 milligrams per liter. And our last example, we've got 7.58 times 10 to the 4 meters per hour, and we want to change that to kilometers per second. So here's our plan. We want to go from meters per hour to kilometers per second. So we need to take kilometers to meters, and we need to take seconds to minutes to hours. Now you need to be careful with the seconds to hours because you can go straight from seconds to hours if you know that there are 3,600 seconds in 1 hour. Okay, but most of us know there's 60 seconds in a minute and 60 minutes in an hour, and that's a little easier. So let's start by setting up our given 7.58 times 10 to the 4 meters per 1 hour. All right, now let's work on our meters first. All right, so we want meters on the bottom to cancel, and we're going to Oh, I wrote that backwards. Okay, so it should be meters to kilometers. All right, and we know that 1 kilometer is 10 to the third meters. Okay, so meters cancels. Now, if we stop right here, we have kilometers per hour. So to cancel hours, it's going to go on the top. So we want to go hours to minutes. So 1 hour, 60 minutes. All right, and then we see the hours cancels. And then we want to cancel minutes by putting it on the top and seconds on the bottom. So 1 minute is 60 seconds. So now we can see that we have kilometers per second. So now we have to pull all of our numbers out and do our math. So we get 7.58 times 10 to the 4 over 10 to the third times 60. Oh, my computer's not cooperating. There we go. 60 times 60. Now, when you put this in your calculator, be very careful because you need to have this in parentheses. You need to follow the correct order of operations. So make sure that when you put that in your calculator, you're going to do that and put it in correctly. And the answer that you'll get will be will be 0.021. We need 3 significant figures here, so 0.0211, and our unit here is going to be kilometers per second. Now you can also write this in scientific notation. Either way is the same.